Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have some parameter pollution in Golang, an exploit in OpenEMR, and using a CRLF injection to bypass Akamai's web app firewall. So, yeah, we'll jump into our first topic, which is the OpenEMR RCE.
Actually,
And I'll
just
let
before
Z.
we, well, I guess you're going to pass over to me anyhow, so I'll just jump
Yeah.
in there. I also do want to say thank you to Mojo for the Twitch Prime sub.
Yeah, I
So
almost forgot. Sorry about that. Yeah.
yeah, so want to give that a quick shout out. In terms of the OpenEMR bug here, it's kind of can be broken down to a couple areas. When I was scanning this one, I thought it was really weird because at just a scan, not really looking at how the bugs came in, they end up mentioning like a rogue MySQL server in kind of this summary area. And oftentimes when I'm looking at the bugs for this, I'll try and get a summary before I just actually dive into them. So I'm like, well, what type of scenario are you really going to have like an application connecting to a rogue MySQL server? Like that doesn't feel like a worthwhile attack. It is. There is a much better attack here. So going into the details on it, it starts off just with the PHP application, kind of has its usual setup, states it has this setup.php file. That file, even after you've done your initial setup, just doesn't get removed. That file will kind of remain even after you've gone through the actual installation. It just sits there and can be accessed. Now, you can't do a full reinstall. We have talked about that sort of attack in the past before, where you hit the installer and you just reinstall with all the attacker controlled stuff, and away you go. In this case, though, you can still invoke some methods. Specifically, they found one that kind of lets them do something, which is actually, first off, in the setup.php, it'll take in a state. So as you're going through the install, you've got kind of the steps that you're going through, and it crafts this installer based off of whatever's in the request. So the installer object is instantiated based on your request parameters. That's important because the installer will actually load the database, user, password, server, port, all that, all the login information for the database is coming out of the request. So while you can't actually do a full reinstall and actually like overwrite where everything's going, you can still invoke some of these states with this malicious installer. And this is because during setup, this is unauthenticated. You can invoke that installer and invoke this state 7 in this case, being where they actually found a way to exploit this. You get the new installer made, that's pointing to an attacker controlled database. Again, attacker controls where it's going to connect to. And it's like, well, what can you do with that? And under a lot of situations, maybe not a ton. Like, okay, it's going to query the attacker's database, but without being able to save something back out. Maybe XSS can come out of that. Maybe you can get some page that'll reflect something. But it is kind of limited. But where they took this was using the load data local infile. So specifically this local infile modifier. What that will actually allow to happen is the server can ask the client. So the MySQL server can ask the database, or can ask the web application to load files from the web application side. So that's where you can have this rogue server it's connecting to, because the installer takes that rogue server, and the rogue server's like, hey, read me in this file from the web application server. And so you can start reading source, you can start reading any secrets and anything that way. So I thought that was kind of a fun twist on the I guess usual approach to the SQL injections, or having having that level of access is a little bit weird. This does depend on the allow local infile being set to on. However, OpenEMR in particular does use that functionality. Therefore, it is likely to be on in this application, although other places, it's going to be a little bit limited if you're able to get this sort of control. You may not be able to actually pull off this sort of attack, but it did work out for them in this case, so they got something with it. So I thought that was kind of just an interesting approach on it. They did also find a unauthenticated cross-site scripting, which could be used. I thought it was a little bit, or it is quite a bit less interesting here. The code for that basically just takes the server request URI and reflects it inside of this onClick handler, specifically inside of this do pop-up method, and then gets the URL and tosses or reflects it right out. So it's somewhat straightforward, but you do have the complication where the request URI is normally going to be like any sort of single quote, double quote in there that you need to break out. That's usually going to be URL encoded because it's part of the URL. PHP is getting that in. There may be some case where it's not. I do know there are some weird things when you start switching around exactly how PHP gets invoked, like versus fast CGI or whatever, versus like the direct calling, and there's all the different ways you can kind of set it up there. So maybe there is something weird in that. They don't go that route. I don't know for sure if there is a route where you might be able to get something unencoded. But the route that they actually went was kind of an interesting quirk in terms of the order of processing that happens. Specifically, that you can include the HTML entity encoded. So that's like your ampersand, whatever the character name is, and then the semicolon. You can do that encoding, and the browser will decode that before it decodes it as JavaScript. So you can kind of inject your characters that way. So inject your single quote using the and a pause semicolon as your injection there. That gets rendered down. This is one of those tricks that like I've been aware of. I mean, just in testing, dynamic testing, just kind of try it and see if it works, not really thinking about how it works. So it was kind of interesting to me to actually have it point out, like, you know, it processes it in this order. Makes complete sense that it's doing that sort of processing. I just never really thought about before. I just tried the test case and it worked. So it was kind of fun to see that called out there as for exactly how they took advantage of the cross-site scripting. And then the last issue here was basically just directory traversal on a file upload. I guess directory traversal. I'm kind of mixing up a couple issues. So this one has a directory traversal, but it's a file inclusion. Not the file upload. They have a general file upload. They don't talk about exactly what the file upload is for, like what functionality actually supports it. But they mention that they're able to write files to the server, but not much more than that. Not told like why they're able to upload them. So we just have to work with the fact they can write things. However, it goes into a directory that they cannot. One, they can't escape from it. So no directory traversal on the upload. And two, it's not executable. So writing PHP in there, it's not going to be executed by the PHP interpreter. So what they did find, though, is, you know, with this this form interface, it grabs the form name that's attacker controlled, and it does a little bit of a generation to turn that into the actual file name for it, form name.plugin.php, checks if the file exists, and includes it. Kind of a classic PHP local file include, and since they're able to do a file upload, they can end up, and that has a directory traversal also. They don't do any sanitization on creating that. They're able to escape that, point the local file to any directory on the server, so if they know where the files get uploaded, they get the arbitrary file include, which gives them code execution because people like to do that in PHP. So yeah, on a whole, like kind of a semi-interesting set of bugs. The first one, I think the exploitation there's kind of interesting, being able to have like that rogue server being in that scenario. Definitely a little bit of a weird scenario to be in.
It's not what we typically cover, that's for sure.
Yeah, it stands out as unique there. The cross-site scripting, having it laid out exactly why the HTML encoding worked was a little bit nice, but like I said, that's something you're probably already testing. You're already using that when you test, so I can't imagine that's like novel information, but I don't know. I just hadn't really thought about before, I guess. And yeah, the LFI, I mean, that's just PHP being PHP in a sense. You don't see a lot of languages where you're like, oh, what file do I need to run? And actually just I mean, some people will do it, but executing a file based completely off of user input like that is, yeah, it's very much a PHP code pattern that you see less in other places. that'll just arbitrarily load anything versus like switching over an action or something better than that.
All right, so we'll get into our next blog post, which is a post on some vulns and Node.js dependencies. 6 CVEs all told, 2 in the Feathers framework, 3 in Sequelize, and 1 Socket.io vuln. So yeah, starting off with the Feathers and Sequelize libs, they started looking there since the target of their code review at the time was built on top of Feathers, which uses Sequelize for doing data manipulation. Basically, with Sequelize, you could express your data in the form of models, and it'll internally translate the requests and interface with the backend like MariaDB or whatever. So yeah, Feathers would export a service which you would interface with over, the HTTP API or optionally WebSockets. And Feathers would handle this request and translate it it would pass it to Sequelize. But one of the various things Feathers supports is querying for special attribute names or filters, which are denoted with a $sign and do various actions. So, like you could pass limit, for example, which will limit the number of results returned. Sort, which will sort based on a config you pass in, etc. There's a bunch of different filters you can do. One of the other ones, though, is the select filter, which you can use to pick which fields are included. Now, the Feathers developers kind of assumed that Sequelize would only take valid column names, and or would sanitize the input coming in for the column names. But Sequelize, on the contrary, considers input going into it to be trusted. So that kind of disparity and not really knowing where the trust lies allows for SQL injection type issues through that select filter, because the column names are just passed straight through. They're not sanitized, and the user can have some control over that. So that was
Yeah,
the
and
first set of...
on the
Go
user
ahead.
side, like that is taken right from the URL parameters. Those
Yeah.
attributes just completely user controlled. In the case of Feathers calling into Sequelize, user has complete control there.
Yeah. So that was the first set of Feathers and Sequelize issues. The next bug comes from JavaScript's type system causing some trickery when parsing Feathers queries. So Sequelize will take some where conditions to build the where part of the SQL query. And as part of doing that, it'll do some type checks on the data that's coming in, and it supports various different types like integers, strings, arrays, buffers, etc. But if it encounters a type that it doesn't expect, it'll fall back on this 1 = 1 or true case. Or it'll also fall back on that if you pass it like an empty array or an array with an empty array as the first element. So yeah, in most cases, especially from the HTTP APIs, this isn't a huge deal because what's being passed in is always a plain object. But in the case of WebSockets where you control the query more directly, you can simply specify like an empty array for the where part of the query and end up selecting rows that aren't intended, hitting that fallback case.
Yeah, and
So that was kind of interesting.
this bug, it kind of relies on abusing how people are using Feathers. Because it comes down to the fact that, like, with the normal usage of Feathers, you may just want to have people be able to, as one of the examples here shows, like doing this, you get message in title equals foo, so it translate into that select where, title equals foo. But you may use, like, for the normal, I guess, process, you probably don't want users having access to the entire database. So under normal use cases, you'll likely implement their what they call before hooks. The before hooks might add the constraints such as like, and user ID equals 1, or like setting some properties. They'll have some use case there where they're actually adding restrictions, so the default isn't quite the best idea.
Yeah. So yeah, with the WebSockets, that issue was fairly easy to take advantage of. They did find some other ways to take advantage of it, though. Particularly with like prototype pollution, because they found that Feathers would do a deep copy of the query object when trying to clean it. So you can set the query's prototype to an array, switch it from the plain object to an array, and on subsequent queries, hit that fall through case of an empty array. Finally, they looked at Socket.io. Again, an issue involving types. So Socket.io would allow you to input placeholder values as part of the request, which would then get replaced with the contents of the second message. And to do that, it has a number field attached to the placeholder that it'll use to do the lookup when processing. The problem is they don't actually validate that num field is an integer, and so by just setting it to a method such as reverse, I think is what they use in the blog post, they can again get a query object created with an unexpected type, fall back on that true case, and achieve the same sort of result as the last two bugs. So yeah, a lot of these vulnerabilities reach the same sort of endpoint of hitting this true case in Sequelize, which yeah, I mean, in the context of aware conditioning falling back on a true, it does kind of make sense. Like I can see why they do it. But it does, like, this is one of those cases where it demonstrates why a fail open is a major sink. But again, like it's contextual, and in this context it does make sense to do it that way.
Yeah, and
But it
within
totally makes sense that the researchers focused on that as well.
yeah, like it's kind of coming because of this interaction between feathers and an ORM like Sequelize. ORM, you're using it to query. Why are you querying nothing? Like why are you writing such a query? So like it makes sense that they would, oh, you've sent us in an empty array, that must mean no conditions. I think that is completely fair for Sequelize to have done and written it this way. I'd put a lot of the blame here for most of these issues towards Feathers. Although they do fix some of these things in Sequelize, I think there's value to like the defense in depth. Like they fix, I believe one of the patches is for the those special parameters actually getting a little bit of filtering. But it makes sense they actually have that because that's how a count query, for example, you would set that as the column name count bracket, whatever. Like that's something that you need a way to actually do it. Um, Making it like a flag or having something in there maybe makes a bit more sense. You can do this as more in a more defensive way, but from the perspective of an ORM, I would see that as being used more trusted. And in this case, they're very much going like untrusted data is just being fed right into this ORM. So I don't know. I think Sequelize made some sane choice here, and it's great that they're also fixing some of it. But like the failing to 1 = 1, like you pass in an empty array. What should that mean? Should that really mean a condition of like don't return anything? Like that doesn't feel like a logical. That feels like a surprising response to me, honestly. So the fact that they fail open in this case is really just coming down to the fact that Feathers is being rather permissive in what they're doing here, I think.
Yeah, I'd agree on like the issues being more on the Feathers side than the Sequelize side. So yeah.
Yeah, we had a question chat there. How do you find all of these write-offs? I do have the odayfans.com, which tracks not all of the feeds that I'm following, but it tracks a lot of the feeds that we follow, or that I follow here. It tracks basically the ones that are generally always going to be vulnerability write-ups.
Yeah,
There is a
unfortunately, some of the ones where there's like a lot more noise, or like it would add a lot of overhead to maintaining the site, so that's why they're not on there.
yeah, there's a lot that I just couldn't come up with a filter on, but there's a lot of posts that we just follow. And yeah, I just have like a ton of feeds that I'm looking through, usually on the weekend before these episodes.
Yeah, we don't really shout out Ode fans as much, but it is like pretty cool. And we also have a feed channel in the Discord that you can subscribe to as well. So uh, yeah, that's where a lot of the topics come from.
Yeah, our Discord channel is based off of Ode fans also. It'll be a slightly different order just because of how they get published, but effectively the same feed.
Yeah. All right, so I guess we can move into our next topic here, which is a Medium post on exploiting parameter pollution in Golang web apps. And yeah, Z, I'll let you get into this one.
Yeah, and this one's fun. Again, parameter pollution, it's vulnerability we know about. You don't see it all the time. And this is really kind of a case of a double parsing. So parsing the same value twice is kind of the code smell that I'd be looking for in this sort of issue. Because what ends up happening is you have the main authorization check see the code here. You've basically just sorry, there we go. The line 9 here. The team name, it's grabbing this team name and just looking at the URL, grabs a query object from it, get team name. And that's kind of part of its authorization check there. That's all it does in this. And this is the check authorization handler. It's doing the auth check. So it just grabs out the URL and grabs it from the URL explicitly. And that matters because later on when they get to the pipeline, and in this case, basically, you've got a CI/CD sort of application, concourse, and so a pipeline is just like your next build steps. So it's going to be privilege off, it's going to have a name, but that's kind of what's going on here. When it gets to the actual pipeline and figuring out like what pipeline is it actually supposed to be executing, it changes. Instead of parsing the team name using the URL, it'll parse the team name just using form value. Now, form value will give you the URL parameter value, but the post or put bodies actually take priority. So if the same value exists in both or multiple places, it just returns the first one that it finds, and the put and post bodies gain or have a priority over what's in the URL, which means you can provide it, or you can provide this authorization check. When that happens, you can provide it a team name that is different from the team name that the actual pipeline handler, this pipeline scoped handler, but the handler for the pipeline, that one actually uses. And because of that difference, now it's, doing basically a wrong authorization check. They're able to provide a team that they are allowed to access for the first auth check. The pipeline isn't doing the auth check. It's just looking at what pipeline tree, assuming the auth has already been checked. It reads a different value, giving them access to a different pipeline. So honestly, it's a really cool bug, and I love seeing these sort of desyncs or differentials really in parsing.
It's almost like seeing a double fetch in the web with how it works, kind of. It's the same sort of scenario you end up in.
Yeah, I mean, with the double fetch, you've got more of like the data being changed out from under you, where you're reading the same data and somebody's changing it. But, you are fetching it twice, and that is creating a problem. So, yeah, I see where you're going with that. Yeah, it's a fun bug class. I want to see more like this, but it's so contextual as to how you'd actually abuse this, or if it can even be abused, that it's hard to test for, but it's cool to see it.
Yeah, I think this is the first time that I can recall seeing an issue like this that we've covered. Maybe we've seen one before and I just don't remember, but it seems like a unique issue.
Yeah, I feel like we've talked about parameter pollution more in the sense of having the same parameter included multiple times and then having bad parsing there. So say
Yeah,
one
not so much on
application,
like this discrepancy sort of thing. Yeah.
yeah, like I think they were inspired by this asset no post, which I guess they don't include a link to it, but I'm pretty sure we covered it, and it was talking about parameter pollution Golang, and it had to do with more that level parameter pollution, where you have the same parameter in like the URL multiple times and gets parsed differently. At least I think I've seen a few posts about that, and I feel like we covered one or did a shout out for one of asset notes, so I'm kind of going off memory there. But yeah, it is something we've talked about before. I don't think we've seen it, especially not in this case, like the post versus get parameters.
Yeah, that's what I meant. We definitely talked about like parameter pollution before, but like not in this way. So
Yeah, yeah,
yeah,
this one's
pretty
fun.
cool post.
Easy to follow.
Yeah, pretty quick read. So all right, so we'll get into our next post, which is was put out by Praetorian, and it was on a CRLF injection they found in like an undisclosed application, and they found a way to abuse it to bypass Akamai's web app firewall. So CRLF injection, for those not familiar, it's basically what it sounds like: areas where you can inject a carriage, return a new line character or escape sequence, and basically break some kind of parsing or scanning functionality that depends on using new lines to separate data, which is particularly relevant when you're talking about things like HTTP requests in HTTP 1, where it's new line based. And it's something that web app firewalls would take an interest in. So Yeah, Praetorian was doing an engagement for an unnamed customer, and as part of that, they used Nuclei Scanner, and they found some CRLF in a particular endpoint where input from the URL was making its way into an HTTP request. I think the test payload that they showed off was doing like it would pass a new line and then pass a set cookie header, and they were successfully able to get that cookie set and demonstrate the CRLF. Unfortunately, they don't really go into detail on where that came from. Um, they more focus on how they exploited it with Akamai's web app firewall in play. So, yeah, they get into that a little bit. They start off by showing their initial naive attempt at exploiting this, just trying your straightforward XSS payload, trying to inject that into the response body. But Akamai web app firewall saw this and denied the request. And while they could have went for a more run of the mill web app WAF bypass, they decided to take advantage of their header injection primitive to come up with a more interesting bypass. And what they did there was they would inject some headers, particularly the content encoding header, and set the content encoding so that it was compressed. And they would sneak their XSS payload through in compressed form. So that would pass through Akamai's WAF. It would see, okay, this just looks like random data. Like I guess it doesn't really consider decompressing the request to try to scan for that. So yeah, I mean, you kind of smuggle your payload through via the compression. It's kind of a neat way of taking advantage of it. Ultimately, it is just bypassing the firewall by taking advantage of the compression, but doing so by injecting a header this way is kind of neat. It's not something you really see very often, and they're just taking advantage of the exploit scenario they had. So that was pretty cool. Like I said, though, unfortunately, there really isn't any details on the actual vulnerability itself. They're pretty, mum's a word on that, but the exploit was still neat.
Yeah, that's the thing with this one. The vulnerability CRLF injection, generally, that's just coming from reflecting some data without sanitization. Like, this doesn't look like it's anything more complex than that. One of the other things that they did kind of have to do was Akamai would also block the carriage return and new line. So, despite the fact that we're talking about this as a CRLF injection, technically for their exploit, they do only do the new line injection. A lot of HTTP parsers are reasonably permissive and will actually accept the new line instead of just RN. It'll take just the new line. Um, Usually that just comes from it parsing, just looking for the new line and trimming. Kind of any extra white space, so kind of ignoring whether or not there is a carriage return. So that is one aspect here that may not work in all situations. But I did like the whole exploitation strategy here, where, like I said, they use the primitive that they had, which is this ability to inject headers, and use that to get around the WAF. It's a cool little technique. It's something to keep in mind if you kind of end up trying to exploit this sort of issue. It is very specific to this particular vulnerability. Like, you need to be able to inject headers. That is not a common primitive outside of this sort of attack, outside of this sort of vulnerability. So it is a bit limiting there, but it's fun to see just using the logical functionality to your advantage rather than kind of going the hard way of actually trying to find a payload that Akamai wouldn't ban.
Yeah, and like you said, like CRLF injection, like generally it's a pretty straightforward vuln. What I would like more details on though is um you don't really see CRLF injection in the context of HTTP headers very much. Um, at least not like I can't really recall many cases of it.
It
So I
used
would
to
be curious
be
on a bit of the background of like what the application's doing here to allow this. But yeah, I mean, we just don't have that information.
it used to be pretty popular actually. In like the mid 2000s. And then it kind of died out, and then with request smuggling, people were kind of looking for this sort of thing also around the same time. So it kind of came back to life a few years back. I mean, it always had a bit of like, oh no, it's been around. It's one of those things where, especially adding custom headers is one of the places it can come as one thing just
Hmm.
kind of reads. In this case, they make it seem like it's reading the path actually, and including that in header. So it's doing like X original path or something as it does some rewrites and including it there. That's one way you're going to see this kind of get introduced. Um, trying to think about where else I've kind of seen it. I feel like yeah, I'd really have to go look some of my notes because I've got in my head, I'm thinking about a case where I've seen it with a host header, but then that feels just so insane that there's no way my memory's right about that. So I'd have to go and see if I can remember exactly the vault I'm thinking of. I don't know. It's been around for a while. It's one of those things that had some popularity. Now most things are kind of aware to prevent that issue, so they're just automatically filtering values, so you can't just go and set a new line somewhere in there. Location headers. That's the one I was thinking of. Doing redirects based off of user input. Um,
Yeah, that
those
makes sense.
were another common place where you'd see this.
Yeah, that totally makes sense now that you mention it. All right, fair enough. But yeah, it was kind of a neat WAF bypass. I was a little bit surprised that Akamai didn't consider like compression, because I feel like I've seen compression used as bypassing for, well, not just WAFs but like anything like that that does like signature scanning or whatever. It feels like one of the more common tricks in the book, so I thought they would have tried to do the decompression if they saw, because you can like determine, well, I mean, the header would say directly if it was compressed data. So yeah, I was a little surprised Akamai didn't handle that, but yeah, I mean, and they also call it like there's other WAFs that would be vulnerable to this too, of course. Like, it's not really specific to Akamai. It's just that's kind of the big player in the industry, so that's where they targeted, and that's what their what they came across on their assessment. But yeah, yeah, like I said, I was just a bit surprised that Akamai didn't catch that, but I'm assuming that's probably changed now. So
Yeah, that's one of the like I don't even know actually if they mention Akamai going to patch this or not, because it is a big ask to say, okay, everything incoming you also need to deflate or decompress using all known methods to make sure. Well, I mean, there's only the few main supported methods, but to make sure the payload isn't also done that way. Like, it is something they could do. It would be similar to like decoding a base 64 encoded payload. Is that necessarily something you need at the WAF level? Um, like, it could be done,
I
but
mean,
I
that's the
kind
thing.
of
Like, you wouldn't have
understand.
to do it on every request. Like, you would just need to check for the presence of that header, because like the browser would need to know too, for this kind of attack to work. So yeah, like I feel like the WAF should be
Well,
like
no.
checking for those headers
So
and doing that, but
the thing is, you would have to do it on all of them because that header's only going to be present on the response, not the request that's causing the response. Because the header, so you have the
oh,
request
okay.
going in that has the compressed data that's encoded in some way. Um, that needs to be filtered at that level, and then the response is like, "Hey, this is encoded or compressed or whatever." Um, so they're not necessarily going to see that uh, it's encoded, therefore decompress it. Like, they're not necessarily checking the responses to see if something's been reflected there.
All right, fair enough. Fair enough. All
And
right.
I8BR mentions, I'm trying to think which WAF it was that was bypassed, got SQL injection, including by including seemingly a bunch of different keywords, and they just disabled the WAF. I think you might be talking about the JSON bypass, which we covered. I think it was before winter break. Uh, but I think it was this post, this JS on security off, where basically if you included one of the JSON keywords, say like, hey, this is a JSON query, like the at sign angle bracket, the WAF just like turned off. I think we were surprised by the fact that like just doing that and suddenly you can do whatever you want. It was rather surprising to me, so I'm thinking that might be the post you're thinking of.
That was a pretty good one. Yeah. All right, so we'll move into our last topic here, which was posted by Star Labs, and it's a Microsoft Azure account takeover. Z, I'll let you get into this one.
Yeah, and this one, honestly, there isn't a lot too interesting here, except for the fact that uh takes post messages, and they do some origin checking on it. Makes sense. You're going to validate the origin. And it has this wonderful setup of regex to say what the valid frames are. And you'll notice that one of them kind of stands out because all of these backslashes throw at the first ones, and this one just doesn't have them. Importantly, got the little doc character, and it doesn't escape that. So the origin checking is bad here. This regex, so if you don't escape the doc character, that's basically saying, or dot is a wildcard in regex, so it'll match any character there, including a dot, but also anything, so you can just register this domain and send your request out. Once you could send the request to it and have it be a valid origin, the actual exploitation here was relatively trivial. They took some of the data out of the message and just assigned it right into inner HTML in a couple places here. One on an error message for no data, and the other being the chart title. Those two places get signed on inner HTML. The course configuration will allow for inline scripts, so straightforward XSS. So that's, it's not a super interesting bug, but I think it's fun to see this regex issue, so I figured I'd call it out. That is also something we did on a Spot the Vuln one, so kind of a case of the Spot the Vuln, in reality.
Yeah, it's kind of fun seeing the Spot the Vuln challenges being reflected in real blog posts. So, yeah, and like you said at the time, like it's very easy to make those kinds of mistakes in your expressions. So,
yeah, like it stands out way more in this case because you have all these other regex entries that do the escaping properly, and then there's one that just was probably added later, where they're like, oh, we need this, and just copying it in, and like not really understanding, I guess, regex that well. Like it really stands out here, but normally if you had just a set of URLs and the dot's not encoded, like you don't think about the escape aspect of it. So it's really easy to overlook, especially when you don't. I mean, it's easy to overlook when you don't look at it, but that's necessarily true. But yeah, it's easy to overlook when you don't have everything else kind of pointing you towards that issue, because the domain looks fine as is.
all right, so that's all the topics that we have for the bounty episode this week.
It was a
Thank
high
you
level
everyone who tuned in.
binary episode.
Yeah, it was a very high level binary episode. Yeah, like I said in chat, I'm tired, so apologize. So yeah, VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor for those that want to listen on other platforms. If you want to join our Discord and follow us on Twitter, links to those are down below or in the chat. And we'll be back tomorrow for the actual binary episode at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.